Manager for Team MU Grüne Welt 2019. We are from Multimedia University, Melaka Campus, Malaysia. I'm here today to introduce to you guys about our V5i. V5i is the car that we use for Shell Eco Marathon 2018 in Singapore. Okay, first I'm going to introduce that this car is based on modular design. Modular design means that we can disassemble the whole car into many pieces to ease our transportation of this car to our competition site in order to save the cost of logistics to transport this car. First, I'm going to talk about the design of the chassis. This chassis was previously made from aluminum T-slot. This is aluminum T-slot. This material, okay? In 2018, it's our first time of implementing composite material in our chassis, which is this and this. This is made from the mixture of jute fiber and glass fiber with epoxy, and we compress it. All this is made in-house by ourselves. But in this year, we are improved and we are going to make our chassis whole piece purely by carbon fiber, since the prototype of our composite material have proven its reliability during Shell Eco Marathon 2018. This is the example of carbon fiber that we have made to make our chassis for next year competition. This carbon fiber rod is hollow and is made by our own self in-house with our own mold. This is the mold. Okay, to let you guys know more about composite material, for our 2018 car, which is the jute that you see just now, this is made from jute fiber. This is jute fiber, okay? And for this year, we are upgrading to a much more expensive material, which is carbon fiber fabric. This will improve the strength and much significantly decrease the weight of the whole car. Now I'm going to talk about how we make these carbon fiber rods that we are going to use to make the chassis of Eco V6. As you can see, this carbon fiber rods is hollow and very thin, even though we use like about 8 layers of carbon fiber to make this rod. This rod is purely made from carbon fiber fabric and epoxy, using the mold that we make ourselves with CNC machine. This is the mold. This system of making carbon fiber rods is actually common in making carbon fiber bicycle. It's actually the same system. This is called the bladder inflation system. Why we call it the bladder system? As you can see, have you ever wondered how we make this hole hollow? It's actually by laying all the carbon fiber layers, layer by layer, and we will insert a tube so that we can increase the pressure of the tube to press the carbon fiber against the wall of the mold. Okay, so this is what we call by bladder, and this is bladder inflation system. So after we change the material from aluminum T-slot to carbon fiber rods, we expected a very significant change of weight in our car. We estimate our chassis to be around below 6 kg. As you can see here are all the carbon rods that we have prepared to make our Eco V6. These are the aluminum T-slot that we have been using for 3 years, and we finally gonna use carbon fiber to improve the weight of our chassis. Since last year, we have been experimenting on glass fiber. This is glass fiber. Okay, so for now, I'm gonna compare the weight of all this material. These two element T-slot are actually equal to the length of these carbon fiber rods. Okay, first I'm gonna measure the weight of this element T-slot. As you can see, it is 841 grams. For your information, all the rods that I test is having the same length. This is for glass fiber. Glass fiber is 564 grams. And for the carbon fiber rods, these are actually the thickest that we make, which is 8 layers. It's just 438 grams. And these have much more strength compared to the glass fiber. So this is the choice of our material for this year.
Hi, my name is Chamdoje, and I would like to talk about the transmission system. Okay. In the past 2 years, our car is using the gear change sprocket, and the gear ratio is 1:12. We are using a 2-stage gear reduction, and the gear ratio is 1:3 for the gear, and the sprocket is 1:4. But last year, we decided to switch to in-wheel hub motor, which is this. Okay. In 2018, we started to implement composite material to use on our car, which is the swing arm. And this swing arm is used to hold the hub motor. The material we use is glass fiber, which is cheaper material compared to the carbon fiber. And it is shown that compared to the gear change sprocket mechanism, in 2018, the transmission system is reduced by 40% in weight. And it is also proven its reliability in the competition. But in 2019, we will start to switch to carbon fiber, which is this rod, and it will further reduce the weight.
Hi, my name is Sema, and now I'm going to talk about our shell design. For the V5 and V5i design of our Team Grüne Welt, we have been using the techniques of using the aluminum hollow bars. The profile is actually 1/2 inch times 1 inch. And we actually join the aluminum bars together by using the aluminum tin plates, which is in this shape. We cut into the strips and join them using the rivets. And to join the skeleton onto the chassis, we actually uses the bolt and nuts. And it is connected to the T-slot bar of the chassis. And for the cover of our shell, we actually uses the 1 mm PC sheet, which you can see here, the thickness. And it is actually quite strong. And the way we fix the cover onto our skeleton is actually using the rivets as well, as you can see over here. Okay, so for our upcoming competition, which is in 2019, we plan to improve our design by replacing the aluminum bars with 3D printed parts. And we are going to use the PC sheet as well as the previous competition. And also we plan to replace the screws by using 3D printed screws. The purpose of doing so is to reduce the weight of the
Hi
shell.
everyone, my name is Lim Ting Shuang, and for now I will further explain to you the steering system of this V5i. Going into the car, we can see the steering wheel is only a simple plate, and for the brake we are using a hydraulic bicycle brake system, and the steering mounting here is a 3D printed ABS. The knuckle is joined by ball joint, and we are using low resistance rolling tire for both of our front wheels.
Okay.
Our steering system include positive caster angle, Ackerman steering system, and also the kingpin inclination. As for 2019 spherical marathon competition, the improvement we will make is to use carbon fiber as our steering rod, and also foot activated for both front wheel for the braking system, and all of the steering linkages, as you can see now, is below the car. As for 2019, we will move all of the steering linkages above the car surfaces for easy maintenance. And another advantage is that the bottom of the car will have a very smooth surface to reduce air drag resistance. That will be all from me. Thank you.
Hi, my name is Lim Huang Sheng. I am head of the electronics division in Grüne Welt team. First of all, let me introduce the block diagram for the overall electronics energy system. Looking at this overall block diagram, it consists of a 48-volt battery for energy supply, and it is connected with a 30 amps fuse and 2 emergency switches in series. The emergency switches will be mounted inside and outside the vehicle respectively, and it will be easy to access during the emergency event. They will cut off the system for safety purposes. Besides, it consists of a joule meter, which will be provided during the event, to measure the energy consumption of the motor driver board. The motor driver board is used to commute and control the speed of the brushless direct current motor, and it is purposely built by ourselves. There is a soft start module in between the joule meter and motor driver. It is an optional module that can help to reduce the high and rush current during startup. Besides, there is a throttle connected to the motor driver, and it is used to provide the speed signal to the motor driver to control the speed. And the throttle is integrated with Deadman switch for safety purposes. Moreover, there are 6 wires in between BLDC motor and motor driver. 3 of the lines indicate the 3 phases input of BLDC motor, and another 3 lines indicate the motor hall sensor input to the motor driver. Besides, there is another circuit for horn, in which it will be powered by 12 volts. The 12 volts will be stepped down from 48 volts main battery to power the horn. The horn button will be pressed in every car overtaking events. Now, let's look at the motor driver board that I designed. In this motor driver, it consists of inverter circuit in which it has 6 power MOSFET as shown in the red circle to commute with BLDC motor. Besides, to control the on-off of 6 MOSFETs, MOSFET driver is required. In the orange circle, there are 3 half-bridge MOSFET drivers. Each MOSFET driver is capable to control 2 MOSFETs. Moreover, there are current sensing analog circuit on board as shown in brown circle. It is used to measure the real-time current value of the phase current. There are also wire-to-board connectors for motor hall sensors and throttle, as shown in the purple circle and green circle respectively. The current measurement and rotor position measurement that done by hall sensor are used to commute the BLDC motor, while the throttle signal input is used to control the motor speed. There are 3 phases output wires on top of the board. They will be connected to the BLDC 3 phases input. The 2 wires at the left side of the board will be connected to the battery or joule meter. The microcontroller that will be used to control the BLDC motor will be either Arduino or Nucleo board. The program will be written to commute with motor driver. The motor that we will be used is the 1500-watt hub motor from Pagani bike. This is the gearless hub motor with max speed around 520 RPM, and max torque around 30 Nm. Next, let me explain about the fuse that we are going to use. This is the fuse from the car battery, and we are going to choose the fuse that has 30 ampere in current rating. Now, I will explain about the battery that we are using. This is the picture of the outlook of battery, and this is the inner looking of battery. This battery is built with 39 pieces of LGHG2 lithium-ion battery, and it has 3 parallel network that has 13 cells in series. This is the wiring diagram of the battery. Besides, this is the data sheet of the battery management system in the battery. The nominal voltage for this battery is 48 volt, with max voltage for full charges around 54 volt, and the total capacity of this battery is 9 ampere hour.
As my team have finished explaining the design of Eco V6, on behalf of MAU Grüne Welt, I would like to thank all the technical team of Shell Eco Marathon Asia, and we hope that we will pass the phase 2 registration. Thank you.